Welcome to Spaceverse, your portal to cosmic adventures. For thousands of years, people have looked up at the night sky in wonder, building theories, writing equations, and trying to piece together our role in an immense cosmic story. We thought we understood the rules, from the birth of the first galaxies to the way planets form, but now that foundation is starting to crumble. The James Webb Space Telescope, the most advanced observatory humanity has ever launched, has uncovered things we weren't supposed to see. Ancient galaxies that shouldn't exist, planets that defy the laws of formation, structures too perfectly arranged to be random, and even a faint, rhythmic signal with no natural explanation. This isn't just another chapter in space exploration. This might be the moment where everything we thought we knew about reality is tested and possibly rewritten. Webb may have delivered not only a discovery but a message. If its data holds up, our picture of the universe is incomplete, or worse, wrong. It started with deep field observations, Webb's stunning images capturing the most distant reaches of space. The beauty was obvious, but hidden inside were anomalies that left astronomers uneasy. In the galaxy cluster Abell 2744, Webb revealed points of light lined up with uncanny precision, along with symmetrical arrangements that don't match the messy process of galaxy evolution. Over in the barred spiral galaxy NGC 1365, unusual movement patterns hinted at gravitational forces behaving in ways our most basic models can't explain. At first, scientists dismissed these as chance alignments. But the more images they examined, the stranger it became. The patterns weren't isolated. They kept appearing, too frequent, too perfect. It began to look less like coincidence, and more like some form of order we don't yet recognize. Then came the discovery of a planet that broke every rule in the textbook. HIP 65326b, located hundreds of light years away, is a giant 7 times the mass of Jupiter. It orbits its star 3 times farther out than Neptune does from our Sun. And here's the mind-bending part. Its host star is only 15 million years old. That's extremely young on the cosmic timeline. By all accepted theories, a planet this massive, this far from its star, simply shouldn't be there. There's no visible protoplanetary disk, no leftover debris to form it, and no gravitational reason for it to stay stable at that distance. Some astronomers have started asking questions that sound more like science fiction. What if this planet didn't form here? Could it be a leftover from an older star system? Was it moved or even deliberately placed where it is now? The surprises didn't stop there. Webb captured one of the most breathtaking examples of an Einstein ring, the effect of gravitational lensing, where a massive foreground galaxy bends the light of one behind it into a halo. The ring surrounding galaxy J418 isn't just good, it's almost mathematically flawless. A complete, unbroken circle of light, so precise that even veteran scientists were left stunned. For this to happen, the two galaxies must align with microscopic precision, down to fractions of a degree over billions of light years. Yes, gravitational lensing is real, but this level of perfection is astronomically rare. It's led some to wonder whether there's more to this than chance, maybe a deeper symmetry within spacetime, a hidden geometry we've barely begun to understand. But the most explosive discovery yet? Massive, mature galaxies that formed just 180 million years after the Big Bang. In human terms, that's like a baby speaking fluent poetry, impossibly early. By our models, the early universe was supposed to be chaotic, full of swirling gas and debris. There shouldn't have been time for galaxies the size of the Milky Way to form stable spiral arms and shine so brightly. If these galaxies truly are as old as they seem, then our understanding of the Big Bang itself may be in trouble. The event we thought marked the beginning of time might not be the whole story. The universe could have a past far older than we've imagined. Far from any major galaxy, Webb also detected something stranger still, a gravitational lens effect in what should have been an empty patch of space. No stars, no galaxies, no black holes. And yet light from distant galaxies curved as though something massive was hiding there. Astronomers suggested dark matter, the invisible mass we can't see but know exerts gravitational pull. But the lensing here was too strong, too concentrated. It didn't act like a diffuse cloud. It acted like an object with clear mass, edges, and symmetry. Could this be an ultra-dense cluster of dark matter? Or something entirely different, something constructed, ancient, and invisible, still warping space in silence? Then came the filament. Webb spotted an intergalactic structure over 1 billion light-years long, part of the cosmic web, the vast network connecting galaxies. But this one was unique. Its galaxies followed parallel paths. Its voids repeated at exact intervals. Even the redshift readings formed a pattern, like waves on a grid. Mainstream cosmology says gravity shaped these structures over eons, but the symmetry here is almost mechanical. Some suggest if the universe had a designer, this could be where we'd see the fingerprints. The more scientists examine these gravitational oddities, the stranger the theories became. One idea, once considered fringe, is now being seriously discussed. What if dark matter isn't just inert? What if it stores information? Not information like a computer, but something deeper, a cosmic memory. Across Webb's observations, certain galaxy clusters mirrored the shapes of far older ones, almost like echoes repeating through time. Maybe, as the universe expands, dark matter holds onto the blueprints of past structures, shaping new ones in their image. If that's true, then every spiral, cluster, and cosmic void might be part of a design older than time itself. And finally, the most unsettling find of all. During a deep field scan of an empty region, a void, Webb detected pulses. Light fluctuations too regular to be random, too faint to come from any known star. They didn't match pulsars or quasars. They repeated at perfect intervals, and then stopped. At first, the team suspected a glitch, reflection, interference, a processing error. But after running the data through independent systems, the pattern remained. The source had no visible star, no heat, no gas, just a steady flash, precisely measured, as if on purpose. NASA has remained silent publicly. But behind closed doors, some researchers are asking an old, uncomfortable question. What if it's a message? Not one meant to be read, just one meant to be noticed. The James Webb Space Telescope was designed to reveal the past, to peer back billions of years and show us the young universe. But it may have shown us something else entirely, that we are part of a system far older, far more precise, and far more deliberate than we ever imagined. Galaxies that shouldn't be there. Planets that defy physics. Signals without sources. Structures that look like the work of intelligence. This isn't random. These are measurable, undeniable clues that our universe may be stranger than science has ever dared to admit. And if these patterns are real, if the pulses are deliberate, then we might have to face a possibility more profound than alien life itself. We have never been alone. Not in space, not in time, not even in thought. Maybe Webb hasn't just mapped the early universe. Maybe it has uncovered something waiting for us to finally look deep enough. And now that we have, we may never see the stars the same way again. So what do you think? Are these discoveries the first hints of something more? Or are we simply seeing our own desire for meaning reflected back from the void? Here on Spaceverse, we'll keep exploring the mysteries James Webb and other missions uncover, galaxies that shouldn't exist, planets that defy physics, and signals that challenge everything we know. Subscribe, turn on the notification bell, and stay with us as we journey to the very edge of the unknown. Because out here, the next light in the sky might not just be a star,